Hello everyone, this is Sandeep here from Physics HQ. Continuing with the lecture series of solving MCQs and sums from Physics textbook of Maharashtra State Board New Syllabus 2020. In this video, we will be covering sums of Chapter 1 Rotational Dynamics. This is the second part. If you have not seen the first part, please go through it. So let us start with this video. A motorcyclist is undergoing vertical circle inside a sphere of death. The speed of the motorcycle varies from 6 meter per second to 10 meter per second. Calculate the diameter of the sphere. How much minimum values are possible for these two speeds? So let us understand, when a biker is going through a vertical circle, the velocity at the top will be minimum. So velocity at the top is minimum, and this is given as 6 meter per second. And when the bike is coming down at the bottom, the speed is maximum. So velocity at bottom is given as 10 meter per second, right? So when an object comes from top to bottom, it gains speed. When it is going again to the top, it is losing speed. So maximum speed is at the bottom and minimum at the top. Next, they want to know the diameter of the sphere, for which we will be using this relation. Velocity at bottom का square minus velocity at top का square is equal to 4rg. So ये आया कहाँ से? What we did was we used something called as principle of conservation of energy, in which change in potential energy is nothing but change in kinetic energy. So when the particle goes from top position to the bottom position, it is losing height, and when it loses height, the potential energy decreases. So what is the height right now over here? This is equal to twice the radius. So the change in potential energy will be mg to r. Next, change in kinetic energy. So final kinetic energy is at point B at bottom. So we'll write it as half mvb square minus at the top it is half mv t square. What we can do is we can cancel out m over here. What this becomes is vb square minus vt square is equal to, if we put this 2 common from the denominator on the other side, it will become 4rg, and this is the equation we got. So once again, let us understand change in potential energy. So at the top there was this potential energy which is mgh, and the height over here was 2r. Okay, at the bottom, so it is at the bottom, so there is no potential energy over here. The potential energy over here will be 0 because it is at a 0 height. Okay, now when you take difference, so what is the change? mg into 2r minus 0. So that is why we got mg 2r. Now let us go ahead and use this formula to solve our sums. So velocity at bottom is 10 ka square, velocity at top is 6 ka square. This is equal to 4 into r, which is to be found out, and g ka value we will take it as 10. So what we are left with is 40r is equal to 100 minus 36. So 64 is equal to 40r, or you can say r is equal to 64 by 40. When we divide this, you should get 1.6 meter. Okay, so we got the radius. Diameter is twice the radius, so 2 into 1.6 will be 3.2 meter. So we got the first answer. Second, they have asked how much is the minimum values possible for these two, means velocity at top ka minimum value and velocity at bottom ka minimum value. Let me tell you the formulas. Minimum velocity at the top is given by root of rg, and minimum velocity at the bottom is given by the formula root of 5rg. Okay, so root of r we got it as 1.6, and 10 is g ka value, so it becomes root of 16, which is 4 meter per second. And for our case over here, it is 5 into 1.6 into 10. This will become 16 into 5, which is root of 80. Now you can go through the logbook to find this. or we can simply write it as 4 root 5 meter per second. Okay, you can simplify this by using logbook. Please go through the video of logbook also to understand how to find roots using log. So I hope this sum is clear to you all. Let us go ahead. A metallic ring of mass 1 kg has moment of inertia 1 kg when rotating about 1 kg meter square. It is when rotating about one of its diameter. It is molten and remolded into thin uniform disc of the same radius. How much will its moment of inertia be when rotate about its own axis? So over here we will talk about moment of inertia in detail. So first of all, we have a ring. The mass of this ring is 1 kg and the moment of inertia is 1 kg meter square when this ring is rotating about one of its diameter. Okay, so this is one of its diameter. Let us say it is rotating about this diameter. Now it is molded and it is formed in the shape of a uniform disc of same radius. So we will make another circular object. Now this time it is a disc, so it is solid in between. The radius is same, so if previously the radius was r, over here also the radius will be r. And how much will be the moment of inertia when it is rotating about its own axis? When we say own axis, we are talking about the transverse axis. Okay, so if it is rotating about this, what will be the moment of inertia we need to find, right? So let us start. Moment of inertia of a ring about its diameter is given by 1 by 2 mr square, and the value that we have is equal to 1. In the question only they have given mass as 1 kg, moment of inertia as 1. So what we'll do is we'll try to simplify this and find the value of r. So we got 1 by 2, m is given as 1, r square, this is equal to 1. So we got r square is equal to 2. Now moment of inertia of a uniform disc, thin uniform disc, is given by half mr square. Okay, so over here we need to understand that same ring is melted to form the disc. So over here also mass will be equal to 1 kg, right? So let us find this. Mass is 1 kg. R square we already got over here as 2. Since they mentioned that radius is also same, they said that the radius is also same, so we will put same value of radius. So r square is equal to 2, and this gives us the value as 1. So the moment of inertia for uniform disc of the same radius will be 1, and the unit over here will be again kg meter square. I hope you all understood. Let us go ahead. A big dumbbell is prepared by using a uniform rod of mass 60 kg and length 20 cm. Two identical spheres of mass 50 gram and 10 cm radius each are at the two ends of the rod. Calculate moment of inertia of the dumbbell when rotate about an axis passing through its center and perpendicular to the length. Okay, so let us say this is the rod that we have. The mass of the rod is 60 gram. Length of the rod is 20 centimeter. Then we got two spheres, identical spheres on both the sides. The mass of the sphere is 50 gram and radius of sphere is 10 centimeter. So we want moment of inertia about this vertical axis. Okay, so what we'll do is we will do all the calculation in CGS unit, because all units are in CGS. Next we will find the moment of inertia individually for all the elements. So first of all we will find moment of inertia of a rod about an axis passing through its center and transverse to its length. Okay, so moment of inertia of rod in this case is given by ml square by 12. So we have mass m, mass of the rod, length of the rod ka square divided by 12. Mass we got as 60, length is 20 square divided by 12. So 12 5 is 60. 20 ka square will be 400, which will give us 2000. So we got moment of inertia as 2000 gram centimeter square. Now let us talk about moment of inertia of the spheres. Okay, so moment of inertia of sphere about an axis passing through its center is given by 2 by 5 mr square. But we want moment of inertia about an axis which is present over here. Okay, so for this we will be using something called as parallel axis theorem, which says that moment of inertia of sphere with respect to the axis present here is equal to moment of inertia about its center of mass plus mass into the distance between these two axes. So we need to find out this distance. Okay, so this distance can be divided into two parts. This distance is nothing but the radius of the sphere, so radius of the sphere plus the half the length of this rod. So we got this as L by 2 and this part as R, small r. Okay, so we got length of rod by 2, the whole. So this is parallel axis theorem. If you want me to make a video on parallel and perpendicular axis theorem, let me know in the comment box. So moment of inertia with respect to the center of mass is given by 2 by 5 mr square plus values m into rs plus lr by 2. Now if you observe, we got a similar sphere on the other side of this axis and इसके लिए भी same formula आ जाएगा. So what we can write is, we can write moment of inertia of both spheres we can calculate by just multiplying it by 2. Okay, now what we can do is we can take mass common, so 2 into m, 2 by 5 r square, r of sphere, so we will write it as rs square plus rs plus lr by 2 the whole square. Let us put the values and solve this. So mass of sphere is given as 50, 2 by 5, radius of sphere is given as 10. Over here we got radius as 10. The total length is 20, so 20 by 2 will be 10 again. So we got 100. 10 ka square is 100. 100 into 2 will be 200 by 5. Next we will have 10 plus 10, 20 ka square, which is 400. So what we have is 100 into 200 by 5 will give us 40 plus 400, which is 100 into 440, which will be 444,000 gram centimeter square. So for total moment of inertia, what we need to do is we will add moment of inertia of rod plus moment of inertia of both these spheres. What we get is 444,000 plus 2000, which is equal to 46,000 gram centimeter square. So this is the final answer. Answer in the textbook is incorrect, so kindly follow this answer. I hope you all understood this. Let us go ahead with the next sum. A flywheel used to prepare earthenware pots is set into rotation at 100 rpm. It is in the form of disc of mass 10 kg and radius 0.4. Now a lump of clay which to be taken equivalent to a particle of mass 1.6 kg falls on it and adheres to it at a certain distance x from the center. Calculate x if the wheel now rotates at 80 rpm. So the initial frequency of revolution is given as 100 rpm, which can be converted into rotation per second by dividing it by 60. So we get 10 by 6 or 5 by 3 rotation per second. New rotation per minute is 80 rpm. We will divide it by 60. So what we get is 4 by 3 rotation per second. Now mass of the disc is 10 kg. Radius of the disc is 0.4 meter. Then we have mass of clay, which is 1.6 kg. Okay? So initially moment of inertia was half mr square, since the object is in the form of disk, which is equal to half into 10 into 0.4 ka square. 0.4 ka square will be 0.16 divided by 2 will be 0.08 into 10 will be 0.8 kg meter square. So this is the initial moment of inertia, right? Next what we'll do is we will find out the final moment of inertia. Final moment of inertia is what? The initial moment of inertia plus moment of inertia of that clay which has fallen. Okay? Because we have to consider it as a particle which has fallen from at a certain distance x. Okay, so simple formula for moment of inertia is mr square. Mass of clay is given, distance is x over here, so we will write it as x square. So we got I2 as I1 plus mx square. Okay, now according to principle of conservation of momentum, since there is no external torque applied, we can write initial angular momentum is equal to final angular momentum. We can write it as L2 is equal to L1. Angular momentum is given by I omega. So I2 omega 2 is I1 omega 1. Omega can be written as 2 pi n2 and यहाँ पे we can have 2 pi n1. Now we can have this 2 pi cancel out over here and we have I2 is equal to I1 into n1 upon n2. Also we can write I2 as I1 plus mx square. Okay, so what we can do is we can keep mx over here only and put I1 on the other side. What we get is mx square is equal to I1 n1 upon n2 minus I1. Mx square will become, let us take I1 common, what we have is n1 upon n2 minus 1. So let us put the values, or what we can do is mx square is equal to I1 upon m into n1 upon n2 minus 1. Let us solve this. So this will be I1 we got as 0.8, mass is 1.6 kg, n1 we got as 5 by 3 and n2 we got as 4 by 3 minus 1. So this 3 and 3 will get cancelled. What we are left with 0.2 and 1, this 0.8 2 is 1.6. So what we have is 1 by 2, 5 by 4 minus 1. Let us simplify this. What we get is 5 minus 4 by 4. When we take LCM, we get 5 minus 4 by 4, which is 1 by 4. So what we get is 1 by 2 into 1 by 4. So we got x square as 1 by 8, or we can say that x is equal to 1 by root of 8 meter. Now you can use logbook to find the value. You will get 0.3536 meter. I hope you all understood this. Let us go ahead to the next question. Starting from rest, an object rolls down along an incline that rises 3 in every 5 along it. The object gains a speed of root 10 meter per second as it travels a distance of 5 by 3 meter along the incline. what can be the possible shape of the cylinder. Okay, so let us try and find out what is given over here. So first thing that is given is velocity, which is root 10 meter per second. The distance it has traveled is 5 by 3 meter, and let us try and decode what is given over here. So it is saying that when a object is rolling down, the incline is having some angle theta. Now in that case it is telling that while rolling down an incline which rises by 3 in every 5, that means that the height of the incline increases by 3 when a distance of 5 is traveled on the incline. Okay, I'll repeat this. It states that incline rises by 3 in every 5. What it means is, rises by 3 means they are talking about the height. So height of incline increases by 3 when you travel 5 unit on that incline. So this is the length. When you travel 5 unit, the height increases by 3. So from this what we can decode is, we can decode sine theta. Sine theta is opposite upon adjacent, which is 3 upon 5 over here. So we got one more information from here. Sine theta is 3 upon 5. Now to recognize the shapes of object, we will try to find out the ratio of k square by r square over here. From this ratio of k square by r square, we can identify what kind of object is rolling. Yes, it will be a circular object only. It can be a ring, it can be a disc, it can be a cylinder, or sphere. So what kind of object it is, let us try to find out. For a rolling object, velocity is given by v is equal to root of 2gl sine theta divided by 1 plus k square by r square. Now we got velocity over here, we got value of g, we got value of L, we got value of sine theta. We need to find k square by r square. So what we'll do is, we'll take square over here. So we get v square is equal to 2gl sine theta divided by 1 plus k square by r square. Let us rearrange this. What we get, 1 plus k square by r square is equal to 2gl sine theta by v square. Let us put the values. 2, g will take it as 10, L is given as 5 by 3, sine theta we got as 3 by 5, and velocity is root 10. Okay, so the sum is very simple over here. This 5 and 5 and 3 and 3 will cancel out. Root 10 ka square will be 10. So this 10 will cancel out with this. So what we are left with is 1 plus k square by r square is equal to 2. So k square by r square is equal to 2 minus 1. And we get finally k square by r square is equal to 1. Now for this ratio ka value to be 1, there are two possible shapes. One is, it can be a ring or it can be a hollow cylinder. Now how to find this k square by r square ka ratio? By using the formula for moment of inertia. I have already covered this in the MCQ video. Please click on the I button and check that video to have more understanding on how to find k square by r square ka ratio from moment of inertia ka formula for different objects. I hope you all understood this. So that's it from this video. I hope you all found this video useful. Please don't forget to share it with your friends and classmates. This is Sandeep here from Physics HQ signing off.